Hello friends, in a previous video we created this simple flood analysis for a proposed dam. In this video I want to show you how you can calculate the volume of the water that is contained here. So you're going to need the digital train model that we used for the previous analysis, and you're going to also need this flood output, which we're going to use as a clipping mask. So if you want to get this result first before you watch this video, please check the description of the video where I'm going to put the previous video where we did the flood analysis in. So we are going to first convert the flood output to a clipping mask so that then we can clip the digital training model just to this area where the water is sitting, and then we're going to calculate the volume of that area. So to convert the flood layer to a clipping mask, we need to polygonize it. But before we can do that, we need to zero out all of the banding information so it has only one color, and that will allow us to polygonize it. Otherwise, we're going to get a very weird polygonal layer. So let's go under the properties of this layer and go to the symbology tab. We're going to change the render type from multi-band color to single band gray, and then just type 1 and 1 on the minimum and maximum. Actually, it doesn't matter what value you use here, but it's important that it is the same value. And then we're going to press on apply. So this is going to basically convert this to a purely black color, and you see the banding changed. And this is only in appearances. If we actually click on the identify features tool here and then just click somewhere in the black area, you can see this layer still has the 3 bands, and actually it's 4 bands because it also contains an alpha layer or a transparency layer. And so you can see if I just click randomly somewhere in the layer, the values will change. And we don't want this. We want all of these values to be 0 or just have the same value here. So this is very simple to solve. We just need to re-export or export this layer and then re-import it back as a raster and not as a raw data file. So let's right click on this, go under export and save as, and we're going to choose the output mode as rendered image, and then just click on the ellipsis button and save it somewhere to your hard drive. I'm going to call it clipping mask, and the file type is geotiff. So make sure you have geotiff set here, and then click on the add save file to map so it is checked on, and then press OK. Now we can delete our original flood layer, we don't need that anymore, and we have just our clipping mask. If I expand this, you will see it still has the 3 bands, red, green, and blue. This is because it's a raster image, not a raw data image file. And so that's okay. But now if we go under the identify features tool and click again somewhere in the black area, you can see all of the values are zeroed out. So we have just one value here, and this is what we wanted. Now we are going to select this layer, go to raster, conversion, and polygonize. And just make sure clipping mask is selected here and click on run. And we can close out of this. And now we can delete the clipping mask layer. We don't need that anymore. If for whatever reason it also imported like a large box around the area, you can just select the vectorized layer, toggle on the editing, and go under select features, and then just select that area. Just click on it and press the delete button on your keyboard, and that will delete it, and you'll be left just with the area of interest. So with that done, now we can clip our digital train model. So let's select it, go under raster, extraction, and we're going to choose clip raster by mask layer, not by extent. And for input layer, we're going to have our digital train model. For mask layer, the vectorized layer. Everything else can stay the same. Just click on run and exit out of the algorithm. Then you can delete your vectorized layer. We don't need that anymore. And I'm going to call this DTM underscore clipped, or you can call it just flood. And so now we're ready to run the surface volume calculation tool. So in the bottom left corner of QGIS, in the search field, type raster surface volume and double click on this algorithm to activate it. Under the input layer, we're going to have our flood DTM. And now for method, we are going to choose add volumes below base level. Now we need to specify a base level, and the base level is basically the top of our water level. So we need to know that elevation And if you remember, if I select our original DTM, we created this embankment on it. And if I go under the Identify Features tool and click on that, you can see that it's sitting at 600 meters of elevation, whereas our DTM flood was at 595, because if you remember in that video, we left a 5-meter freeboard for no particular reason, it was just for example, but our top water level was at 595. So we need to specify 595 here, and the output of the volume calculation will be in the same unit that your DTM is in. So if your DTM is in metric units, then the volume output will be in cubic meters. So let's click on Run, and we can see this created a surface volume report here. You can click on that to open it in HTML. And you also got your results directly here in the log. But I'm just going to open up the HTML file. And you can see that gave us the volume. Again, this is in cubic meters. Also, there is a pixel count and an area count in case you need that. So this is how you calculate the volume of the water held back by the dam. Thank you for watching. I hope this was helpful. See you in the next video.